Thank you, Andrew. Now, next up, I'd like to invite Emile Aben from RIPE NCC, and he will present to us about the RIPE NCC probes and the programs that they have at RIPE NCC with respect to measuring and measurement of data. Emile.
Thank you, Michuki. Yes, so my name is Emile Aben. I work at the RIPE NCC. And first, how many people do know the RIPE NCC? Okay, so it's not superfluous to actually have a slide here about what the RIPE NCC is. Basically, the RIR system, there's 5 RIRs in the world that distribute IP addresses and autonomous systems, and the RIPE NCC is one of them. As you and yes, so we have 4 sister organizations, and one of them is, of course, is Afrinic. I'll want to go into detail. We have a unified interface for data, which is called RIPE-STAT. URL is here, and when we do analysis, and when there's analysis done to the benefit of the community, we have like everybody has a labs nowadays, right? We also have a labs, RIPE Labs. URL is also there. But the thing is, what the stuff that we measure is that it's global. The internet is global, so our RIS system doesn't stop at our service region, and our RIPE Atlas doesn't stop at our service region. These packets just they pass the Mediterranean into Africa. They pass the Atlantic. So it's only natural to talk about these measurement systems on a global scale and not on any artificial border scale. And so another question you might ask yourself: why do we measure in the first place? And I found this quote, and which I kind of like. Things that we measure improve, and things that we measure and report improve exponentially. And exponentially might be a bit too much, but I think there's this really rung a bell with me. So the question there is, do we want the internet to improve? And so a natural answer to that question would be, if you say yes, then we should measure it, right? And so that brings me to our measurement project, RIPE Atlas. So what we currently have is a measurement network, and it consists of 3,800 or 3,810, last time I checked, devices that measure the internet. And this is a project that is for the community, by the community. And you can see the distribution here, and I'll get back to that later. So how can you become one of these nodes? It's very simple. You apply online, or you come talk with me, and if you promise me that you can have place one of these nodes in topologically interesting locations, you can have it. And basically this is all. So it's just a network, power, you connect it up, and it just works, and it starts measuring. And like a major benefit of actually being part of this network is that you can look at your network from the outside towards your network. So usually, as a network operator, you have control of your network. You know how your network looks from the inside out. But from the outside in, which might be different, you have the power to actually see that. So you have that power at your fingertips, and how I'll explain. So here, a picture of the probe. It is install and forget, USB powered, hosted by and sponsored by organizations and end users. and it's free of charge if you host individual probes. If you want to have like tens of probes, then you typically become a sponsor. So what did they actually measure, these probes? First of all, we have what we call built-in measurements, and that is from all of the probes towards root name servers and some RIPE Atlas infrastructure. So what they do is they do pings and trace routes, they do an SSL cert fetch, and they do DNS queries. So these are typically your network operator troubleshooting toolbox type of measurements. And the results of this are available to anybody. So if you go to the RIPE Atlas website, both like maps of the results and raw data from these results are actually available for anybody. So this is sort of the, you are contributing to having the internet measured. So this is what my fixed measurements from my home network back in cold Netherlands looked like this morning. This is actually a couple of root servers, and as you can see, one of them, I had the red lines are packet loss. So that's what it's going to measure for you right away once you have configured it. Then you have customized measurements, which are you create a measurement to a target of your choice from the probes of your choice at a desired frequency. And you need credits to do this, and I'll get back to this credit system. And another thing that we plan, and which is coming very soon, is that we will do measurements from probes to like regional targets, which we call anchors, which will create a baseline of like the internet at sort of at a regional, at a local level. And for that, these RIPE Atlas anchors have to be placed at well-connected locations. So this credit system, that's something we have in place to ensure that it is sort of you give some, you take some. Right? You by putting a probe in a network, you give the wider community the ability to measure from that point, and for that you need to be credited, and that's actually exactly what is happening. So it is, it's a reward. It's in our credits system. It is 21,000 credits for a full day that you have your probe up, and if you want to do measurements from anywhere in the world from this measurement network, it just costs you a couple of credits. Like a ping costs 3 credits, the trace routes cost 30. So it is to ensure fairness, and the other is to not overload our system. We don't want this to be overloaded, of course. And you can earn extra credits for hosting one of these RIPE Atlas anchors or sponsoring multiple probes. The whole credit system, of course, is documented and at the URL here. So these are in 2013 we had these 6 sponsors, which we are very thankful for. And this is a question that was asked when I tried to explain our probes a lot. I got a lot of questions about security, so I want to, of course, this is something that is based on trust. And so I'd like to explain the process by which we ensure that the thing is as secure as possible. First of all, what these probes do, when you connect them, they will connect to an infrastructure that we have, and the trust material for that is hardwired in the probes. The probes don't have any open ports on them. If you port scan them, you'll not see any open ports. What they do is they will make a single outbound connection on TCP 443 to our system, and over that channel it'll receive commands on what to measure, and then of course it will do the pings, the trace routes, and the DNS measurements. Very important, these probes don't listen to your local traffic. There's no snooping. There's no passive measurements. And if you're really paranoid, you put the thing on a switch and hope the switch vendor is not snooping traffic. And the other thing is that the source code for the probe software is open source. So if you want to see what it's actually doing, source code's there, and you can TCP dump if you want to see what all it's doing. So a couple of use cases of things that you can measure with it. So these are latency measurements to one of the DNS root servers called broot. And guess where broot is? Like orange red is high latency, and green, and that gives it away already. This green here is low latency. And as you can see, this root server only has a single location, so you can see it only serves this region at very low latency, and the rest of the world not. I cut off some parts of the world to make this clearer. No offense to the other parts of the world. Now I have latency measurements to another root server, iRoot. As you can see, they're big in Europe. They have like nice presences. But what I found really nice is that they have a presence in Africa as well. And I checked, they actually have a presence in Rwanda. And you can actually see this one. This probe in Rwanda is actually very low latency because it uses a local instance. And it has a node in South Africa, which is also low latency. So this way you can sort of see if stuff is being local, you can actually see it latency-wise. So if you, for instance, have a data center that is very well locally connected, these measurements will make that insightful for you. So to answer to Michuki a little bit for the business case, this proves by a neutral third party that your data center actually has low latency from your region, right? And for latency sensitive things, that might drive decisions. Another case study, Martin Levy was involved here, I think. This is the Serbian Open Exchange. So this is an exchange in Serbia, which is a country in Europe. There was an LRoot instance deployed here, and this is the latency measurements from a probe in Belgrade, so in the same city. So to go towards LRoot, I don't know which other LRoot instance they had to take, but it was 40 milliseconds. Vienna. So, sorry? Vienna. Okay. So Vienna, and then they could access a local one. Poof, latency goes to nearly zero. So this is the type of stuff that you can show to people, say, see, it really worked. It's not just that we say it works.
This is a random probe with a random path.
Oh yeah, this yes, thank you. This is a home. Yes.
Home user.
Yes. And another thing that we did was actually in end of 2012 there was a big hurricane which basically affected one of the focal points of the internet in North America, New York. And we actually looked at our probes and what actually happened due to this. You could see this as sort of the worst attack on the internet that you can do. Because there's so much going on in that region, and there's so much interconnection. But it actually survived. If you some of the probes locally went down, but that was just because I mean, if there's no electricity to your house, there's no internet, right? But I mean, this is the number of probes that we had during this time, and. Yeah, a little bit of it. It's not really clear from this picture that there was a dip. But what you see here in the upper picture is that the path through New York went down, while the path through the Ashburn area, which is another very important area, went up. So this type of stuff, a global measurement network allows you to see this type of stuff. And the picture here is actually for this destination. The red things here are probes that went through New York before the event, and after the event they didn't. And the blue ones, they stayed, the traffic still went through New York even during the event. So that's the type of stuff that you can see with a network like this. Yeah. So a new thing that we're doing is Atlas anchors. And I really like this picture for sort of, it shows what we're trying to achieve, which is have like steady anchoring points in this whole sea of almost 4,000 of these small probes. So these are like well-known targets. So these are things that the measurements also go to, not only from. And they're basically more powerful measurement devices. They're typically 1U boxes in well-connected locations. We have 14 of them deployed currently, and the goal is to have 50 deployed by 2013 and have them globally deployed. So 10 in Africa would be a really good outcome. And the benefit of doing something like this is that your local probes can actually connect to a local destination, and you see what the local situation, the local connectivity is. Is there tromboning, or and it also provides you a long-term a long-term view of what things look like. Yeah, so to go back to, so this was the first picture, and yeah, here I also, by the way, I also took off Hawaii and Alaska where we have probes, and in Svalbard, which is an island near the North Pole, we also have probes. So this is what our deployment map looks like, and as you can see on this map, we are underserving Africa a little bit, but the next map makes that a little bit more clear, and this is on a country level. So the yellow is where we don't have probes deployed, and so one thing I would really like to achieve is for this global, it's a global effort, right? So for Africa to help globally and the globe help Africa in getting these measurements done and started. So that's what I had to say.
Thank you very much, Emile. Round of applause for Emile. Before you say, just go back a couple of slides.
Yep.
On the I route.
Yes.
Yes. So now notice something here, that there is a dot in Rwanda, which is green for I route.
Yes.
And notice the red dot in Nairobi. Does that mean that we do not get good access to the I route in Rwanda?
That's what it looks like, yes. So now it's measured.
Yes.
Now it can be improved.
Now
right?
it can be improved. Okay. So that's a thought. We can come on that later.
Yeah.
Thank you. Thank you very much.